and welcome. This is Sal Subnis here with SS Multimedia. Today, we're going to be talking about using objects and reasoning.
Alright, so let's go over our objective. So our objective is understanding how to use objects and reasoning to find the volume of cubes. Okay, so we all know what understanding is, okay? And objects, I'm going to be honest with you. I don't know why. I guess we're using cubes, right, in models. So we're going to be using stuff like this, right? But honestly, I don't know why that's in the objective. I'm just putting that in because it's part of the objective, okay? And so basically we're just going to be using these to, find the volume of cubes, which is also this. Okay, this is the part I don't understand because there's a cube, what's the difference? But you know what? That's okay. Life's good. Then there's reasoning. Right, we all know what reasoning is. I've done that enough times. It's basically logic, I suppose. And then the volume. Right? And then, of course, this topic has all been about volume, but I'm just going to go a quick review. Volume, so you have this cube, right, is the length, the width, and the height all added together, right? I know, all multiplied together, okay? So length times width times height equals the volume, okay? So that's what we're going to be dealing with today. Okay, and instead of having to do length times width times height, length times width times height over and over and over and over again, we're going to do something different. Okay, so let's go ahead and get started. So we have this whole big page full of stuff. Okay, and it's a lot of stuff. This is basically our problem time mixed together with our example. I'm going to start off with the top half. So see this line here? Do not look below the line, okay? And I know the moment I said that, I think everybody in the audience is looking below the line. So you can look below the line, but don't ponder on it too much. Just pay attention to the lesson, okay? So, whoopsie daisy. There you go. Now, of course, this is the cube we're going to be dealing with. Okay, so all of these cubes have this volume of 1 cubic centimeter, right? Because it has a length of 1 centimeter, width, and height. Okay, they might not all look the same because a computer is not doing it. I myself am drawing it, so it might not look perfect, but this is what we're going for. Okay, so our first question of the day. What is the volume of this? Okay, now, as I said this, what you might do, you might go on a rampage and start doing, okay, length times width times height, length times width times height. No. Okay, this is what this lesson is about. Reasoning. Is there a point of doing that? No, not really, because there's a quicker way of doing that. You know that every cube has a volume of 1 cubic centimeter. So this cube has a volume of 1 cubic centimeter. Right, this one has a volume of 1 cubic centimeter. This one has a volume of 1 cubic centimeter, and this one has a volume of 1 cubic centimeter. So, rather than doing length times width times height, length times width times height, all that stuff, you can just do this simple thing. 1, right, times 4, because there's 4 cubes, and you know that each one has a volume of 4. I don't know why my computer keeps doing that today. 4. Okay, so the volume of this figure, okay, not of each individual cube, but the figure itself, its volume is 4 cubic centimeters. And that was actually kind of quick. Okay, so now we're going to talk about something else. Is this figure equal to this figure? Right? I mean, who knows? Do we got to do length times width times height? Do we got to do all this stuff? No. Think about it. How many cubes are there? 1, 2. How many cubes are there? 1, 2. We just learned that all you have to know is a cube. So this one has a volume of 1, has 1, right? Each one has a volume of 1 cubic centimeter. So you're just adding 1 plus 1, right? You get 2. So this one has a volume of 2 cubic centimeters. I'm going to write that down there. Right? And this one is the same figure. If you think about it, if I were, okay, so here's a quick test. What I want you to do right now is tilt your head and look at it from a sideways angle. Okay, I'm doing that right now as we speak, so my voice might seem a little off right now. But if you look at it, it's the same figure. It's literally the same figure, just rotated slightly differently. Okay, so there you go. Different figure, but same volume, right? It would have the same volume because it's the same figure. You want to test that theory? This cube has 1 cubic centimeter. This one also has the same thing. So 1 plus 1 equals 2. Okay? Same thing with this. This one might not be a mirror, so if you tilt, it won't look like that. But count the cubes, right? Same with this one, you have 1, 2, 3. 1, 2, 3. So these ones have the same volume. Okay? Now, this would be a completely different story if this cube, okay, this figure, each cube in it, instead of having 1 centimeter, 1 centimeter, 1 centimeter, had 2 centimeters, 1 centimeter, 1 centimeter, right? Sorry, computer keeps doing that today. Okay? Now you end up having a volume of 2 centimeters. This one would end up having a volume of 6, and this one would have a volume of 3. Okay, but since they all both have this made up of the same material, same cube with the same volume, it's the same. Okay, I know I said the same a lot in that sentence, but it should make sense, I hope. Okay, so now we're going to talk about our problem type. So this is our problem time question. That was a very bad box. I'm going to immediately undo that. That was very, very bad. And this too. Let's try this again, shall we? Can I do it? Can I do it? Can I do it? Can I do it? Almost there, almost there. Yes, there you go. I have successfully boxed the problem time question. My problem time is completed. Just kidding. Okay, so now we're going to do this. So the problem is draw a figure of cubes with a volume of 6. Okay, this one, obviously, you cannot post in the comments below. But if you are into this, I want you to take a picture of what you did and then post it or send it to my email. Okay, so now, what you're going to do, you're going to do draw a figure of cubes with a volume of 6. I'm assuming that you've already, while I was talking, paused the video and given it a go. And if not, do that right now. Okay? And we're going to check your answers. So, here's the thing. You could do anything. When I say anything, I mean like almost anything you wanted to do. So let's take a look at this one. Okay? Let's go back here. 1, 2, 3, 4, 5, 6. And these all have a volume of 1 cubic centimeter. So just 1 times 6 is 6. So this one's volume is 6. Anything with 6 cubes in the figure is probably 6. So you want to know the answer to this, the specific answer? Any figure with 6 cubes. Okay? Now, I know what you're thinking. Okay? This one has 1, 2, 3, 4, 5, 6 cubes, right? And then this one has 1, 2, 3, 4, 5, 6 cubes. That was a very bad 3, 6 cubes. But 1, 2, 3. 3. Okay. What game are you playing? You're lying to me. No, I'm not. I promise you, I am not lying to you. Okay? This is a trick. Okay? And what I mean by that is this one, instead of 1 centimeter, it became 1, 1, and 2. So each cube here has a volume of 2 cubic centimeters. So instead of doing 1 times 3, you're ending up doing 2 times 3 equals 6. Okay, the reason I didn't put that down the answer is because I was assuming you were using that 1 cubic centimeter cube. Okay, so if you did this, congratulations on your wit. But I want you to do the 1 by 1 because all you did here was prove that you're quick-witted, but you also need to know the math that goes into this. So congratulations, but make sure you also do the real thing. Okay, so there you go. That is how you can use objects in reasoning with the volume of cubes and figures. Okay, so that's all my work there. Thank you for watching this video. I hope you came out of this video a little smarter and knowing a little more.
Please remember to like, share, and subscribe. And when you subscribe, make sure to hit the notification bell. See you in the next one.